All right, good morning. Welcome to part 3 of designing a trophy truck with ClickRigs. I'm Wiley Davis. This is ClickRigs live stream design time. Just getting some. All right. Let's see where to begin. Just to give a little bit of a recap, we see this here. Last 2 days, we have begun designing a new trophy truck ClickRigs kit. It's going to be a competitor for this one, which is in the store now. This is the Mayday Race Desert version 1. And so that is currently the top of the line, highest performance kit in the ClickRigs store, but we are designing a competitor to that today and yesterday and the day before, and we'll probably be spending about another week on this kit before it's ready. And it is the TBRD01, which is for Thorne Buckingham, who is the fictional driver of this. The MDRD01 is fictionally driven by Mayday, and this is Thorne Buckingham. And so what we're basically doing is we are taking a lot of the good ideas from the Mayday rig, and we're just blatantly copying them, and we're then going to essentially refine them and make them better. And so the first and kind of half of the second day, we got pretty much the whole unequal length A-arm front end completed, and we've introduced a fair number of sort of improvements over this one. Let's go to the regular overhead here, get a little wider. One of the, and this is a recap, but one of the things we improved on the Mayday rig, it's very capable, but it requires a lot more prep between every run. And one of the things that often comes kind of loose is this upper link pin right here, because the way this A-arm setup works, this upper arm is a separate piece from the lower arms, and then so it gets connected with this little pin right here. And so in a crash or a really big hit, sometimes this pin can pop out. Essentially, it's like breaking a ball joint. You can pop it right back in, but it's just something you might have to do somewhat frequently. So this truck is very capable, but it requires a fair bit of prep in between kind of ramp runs or big jumps. Whereas this setup, this entire A-arm assembly, so both of the upper arms and both of the lower arms are actually printed out all as one piece. And so this, where the A-arms connect to the upright, is actually, it's not a separate piece, it's printed right in. So this part will never come undone. And so the only connection points are the inboard upper A-arm bits. And kind of, here's one of the prototype pieces. So that's essentially what that's like. And so these things just fold around like that to make the assembly. So this should be a much stronger and much less fussy setup. The other thing it also gets us is a little bit more wheel travel. We've actually made the truck slightly narrower, but it should have more wheel travel with less angular change, simply because these arms are longer, because we can get them the pivot point farther outboard toward the wheel, whereas on this one, because we have this big upright that we have to have access to inboard of the wheel, it just means these arms are a little bit shorter. And so those are some of the improvements we've been working on. And then a couple of other things too, like with this kit. Again, it's an awesome kit, and none of this damage that I'm talking about is permanent damage. These components aren't actually breaking, but it's simulated damage, which is part of the ClickRigs system. It's kind of designed so if you have a nice clean run, the rigs hold together just fine. But if you take a really bad line when you're running these down the ramp or pushing them over obstacles and jumps, they sort of simulate damage. So parts can come undone. things can loosen up and you need to kind of prep in between runs. And so on this rig too, one of the other things that often happens in a big crash is like this you'll lose a wheel, and that happens in real life, but this rig is a little bit susceptible to that. And so one of the things that we're doing on this one is we're making this setup a lot more robust in terms of wheel retention. And you can kind of see, whereas on this one, if you pull it off, the whole bearing and wheel and tire assembly just comes off together. Whereas here, when you pull on them, the bearings stay retained. And that's because this new setup, I don't know if you can, I might be able to show it here. There's a little lip. So we switched from a semi-round to a hexagonal post, which lets us get a little bit more contact pressure inside the bearing. But then I've also added this lip, which it's a little harder to press through, but once it snaps through, that bearing is not, or shouldn't anyway. Testing will determine that. But in theory, that bearing then should not come off unless you want it to come off. And so that's kind of some of the improvements that we've made so far in the last 2 days. And we are now on day 3. And pop these back on. And then we've continued that sort of toward the rear as well. So the original axle design, again, the bearing comes right off. This is a half round. And sort of what helps retain these, there's a little TPU wedge that gets kind of put in a little slot there, and then you kind of hold that wedge in place, and that helps give the wheel more friction. And that works pretty well. It's just a little bit fussy. And if you do lose a wheel, sometimes you have to track down the wedge, which is small. And so with the new system for the Thorn Buckingham rig here, the TBRD01, we've sort of created, let's actually switch to the CAD here. Let me turn this grid off real quick. I'll hide these components and kind of show you what the new stuff is. So similar to the front, we've switched to a hexagonal retention, and really what that just does, it lets us oversize it a little bit more, so that all the contact pressure is on these points. So there's a good bit of outward sort of radial pressure, but not so much friction that it's really hard to get started. And then the other thing we've done is we've added this little retention lip, just like on the front. But unlike the front, where that whole post can be made out of an elastic material like TPU, this part of the axle is made out of rigid material, so the PLA Pro. And so in order to kind of combine the two properties, I created let's hide this thing, sort of a hybrid component here. And we've got this kind of hub, it's a hat really, that snaps onto the rigid part of the axle. And then if we hide this part, this essentially has this little stud that pokes through the hat, and that snaps on, and again another little retention ring, and then we've got the elastic to sort of in compliance with the bearing. And these bearings in all of the kits, by the way, are just 608 skateboard bearings, and so easily replaced. way overkill for these rigs, but they give them a nice sense of weight, and are very durable, easy to replace. And then it also makes it so you can find, if you want bearings that have a lot less friction and roll a lot more freely, you can easily source all kinds of high performance bearings. So let's turn these things back on. And so today, yesterday we, excuse me, we started in on, we got the front end pretty much all done. I can grab my keyboard here. Let's jump over into the assembly real quick. Again, just kind of bring you up to speed as to what we've got done, what we've accomplished in the last 2 days. So this is our assembly, and again, I'm doing all of this in Onshape. It's probably my favorite CAD system. It runs in the cloud. You can run it on basically directly in your browser. You don't have to install anything, and I'm not. Onshape, unfortunately, is not paying me anything, although I've never asked. I pay them for the privilege of using it, but I'm pretty sure they still, I know they used to, but I'm pretty sure they still have, a free account tier. I think your models have to be public, but it's incredibly powerful. So the CAD tools that are available pretty much for anyone, adult or kid with an internet connection these days, is still mind-blowing to me. I mean, when I started kind of in all of this, a CAD package was $20,000-$30,000 or more. In fact, when I started, it was on a Pro Engineer that had to be run on a Silicon Graphics Octane workstation, I believe is what we ran them on. And it's a lot of expensive hardware. It's an expensive license for the software. The purchase process was a whole thing. It's not like you just go to the mall or call somebody up and say, hey, even if you could afford it. It's basically what I'm trying to say is the accessibility of all of these tools just didn't exist when I was growing up, but now it's just incredible to me, the resources that are available out there for people that are interested in kind of designing and making things. And then you combine that with like the 3D printing and how amazing it is now. We've really crossed the threshold into quality and accessibility, and I just think that's incredible, and I can't wait to see what a lot of people will make as we kind of move into the future. I think it's let's ignore not ignore it, but let's in spite of the doom and gloom and the AI threat, I actually think the future is going to be a pretty interesting place for people who want to make things, and I personally believe that there's still a space for that. People are going to want to see the things that other people have made, and if you're the kind of person that likes making things, there's a lot of neat options and resources out there for you to do so. So here we are. That was a tangent. And this is our assembly, and we've just kind of set it up so that it articulates fairly realistically. We can check clearances, we can get a sense of what the geometry is going to be. I sort of approximated it here because most of the ClickRigs suspension components are compliant mechanisms, meaning that all of the pivots are essentially printed from TPU, which is a very tough and flexible polymer, and so no CAD that I'm aware of, at least nothing commercially available or that would work in this case, is capable of sort of modeling dynamic movement in flexible joints. So you pretty much have to have a mechanical kind of joint there, like a pin joint, or and so the way to get around that, so you can still like get useful movement and simulation, is to you split all these components up that are actually printed as one piece, and you just separate them out. So like this is a piece, this is a piece, and this is a piece, and then you can put mates or joints. So this is like a revolute joint. It just basically pivots. There's one there, and then same here. And then where we get a little tricky, and we're just approximating it, is the joint here is actually a spherical mate. So it essentially replicates like a Heim joint or a ball joint, which is why as this moves up and down, you can kind of see the interference here. And that's not a big deal. In reality, this thing really does sort of operate, because this is flexible in more than one plane or more than one axis. This sort of acts like a spherical joint. The reality is that is probably happening like right around here, rather than in here. It's just because of this snap connection in the circle, it was easier to just kind of add the mate here. But if we really wanted to, we could go in and add a mate connector here, and put the and even split this out, so there's like a line here and then a spherical, like a separate component. But that's not really necessary. I might do that later when we go to render these, because I build these models, a sort of a rendering version of it that lets you position the suspension kind of in different setups, so we can do some renders looking like it's driving over stuff. And in that case, I might go in and clean that up just so that doesn't look quite as wonky. But for now, it's everything we need it to be. So we've got that. Another thing we did yesterday, and something we haven't done on any of the other ClickRigs kits so far in the front end, is we added these rigid material stiffening plates for the lower A-arm. And just to give you a reference, as I design, I pretty much choose the colors based on the material. So in this case, this green color is always going to be the TPU material, and then the grayish black color is always going to be the Polymaker PLA Pro material, which we use. And for anybody watching this that hasn't watched the other 8 hours of video, the ClickRigs system is based really on, aside from like the bearings and the tires, all of the components in the ClickRigs system are really made from just two materials. Everything's 3D printed, and that's the TPU 95A and the Polymaker PLA Pro. And those are kind of the design constraints. So when we're designing all these things, I've got really kind of a set of rules to be sort of ClickRigs legal, and those are, the parts need to be, pretty much everything needs to be made out of those two materials. And I'm not saying we won't ever add them, but I think adding materials should be done very intentionally and be limited to only when adding that new material confers like a really amazing benefit to the system. And so, the materials are going to stay pretty constricted. So right now, the rules are, if it's a ClickRigs part, it's made out of TPU 95A or Polymaker PLA Pro, and all of the parts need to print without any support. And that's in large part due just to manufacturing reasons. The print farm that manufactures the kits that we sell, if we had to process a bunch of support, that just gets tedious very quickly. And so, plus it's also kind of a fun design challenge. You'd be surprised how many things you can end up doing without any support whatsoever. So all of these, basically everything in the ClickRigs store prints without any support. And then also just the quality of that is better. You don't have to worry about kind of the sort of ugly from a cosmetic standpoint, interface layers where the support is. So, and I'd love to see other people, designing their own. We're not, designing their own components for their ClickRigs kit. So, these printers are becoming very affordable. They're very good, and they're very accessible. So I would love to see, the people playing with these rig kits, sort of designing their own components and modifications. And I think, if you can try to adhere to that sort of those ClickRigs rules, it's just it can be a fun way to go. And so, we don't give away the files. Basically, anything that I'm designing here, if you want it, you can buy it from us, and we will manufacture it and send it to you. But if you've got a printer, and you're watching these videos and you're learning CAD, or CAD really well, I would love to see if you want to make a component that fits into this system. I would love to see it. Send it to me, and we can even talk about it here. And so if you've got any questions about how to design stuff for it, I'm all about it. So just reach out and come here and join the chat, or send me a message, and I'll get back to you, because I think, that's a very exciting aspect of all of this. I'd love to see grow a giant community of people that kind of build things out of all the components, and then also design and manufacture or print their own. And yeah, so all right, so that's the preamble. We've got the front end pretty well done. We got the axle improvement kind of made and done, and then now, where we left off, we were going to now design the rear suspension. And similar to the Mayday rig, this TBRD-01 is going to be, A-arm front end. So, very similar to kind of the standard trophy truck plan. I'll have a triangulated 4-link rear end, so a pair of lower trailing arms and an upper triangle link. And so we were in the process of designing the rear trailing arms. And so what I just turned on here, this sort of grid, the whole, again, this is sort of a recap, but the ClickRig system is based on a 10 millimeter by 10 millimeter grid, and then kind of a layer system, which I won't jump back into now, but essentially everything needs to fit on this grid so that parts can be interchangeable between rig kits, because the key concept to the whole system is that you don't just have to build the specific rig that you got in the kit. You can take those parts or buy individual components and remix them and snap them together. So kind of like Legos, you can build your own creations. And so we're trying to sort of hit a balance between, unique parts, while ensuring that all of these parts can be used in some way, in some other form. And so one of the ways that gets done is by conforming everything to this 10 millimeter by 10 millimeter snap grid. And so that's just a tool that I have in sort of the template, so that as I'm designing new parts, everything can kind of match that grid to ensure interchangeability. And so you can kind of see this axle's got snap dots in these locations. These match up. This is your standard domino chassis, and then kind of all of these components all fit, conform to that grid. And so let's go down. I think this is our sketch. And so lower trailing arm is going to connect to there on the bottom side of the axle, and then we'll have to build out some chassis elements, but I want it to connect there onto the chassis, which that's going to give us a 70 millimeter trailing arm length, which is a little bit shorter than the trailing arms on the Mayday kit. I think these are like 80 something. And this is a very long rig, but as I've been saying in the other streams, there's sort of a fictional world called the world of Harley Dome that these sort of rigs exist in, and so each rig has a fictional driver that it's sort of designed for, and that driver has their own personality and their own style, and so when I'm designing these, I try to sort of make the rigs fit kind of what those characters might want. And Mayday is she drives this rig. This is the MDRD01, and this is in the store. She is kind of a wild driver. She just kind of wants to point the truck at the obstacle and just let it eat. And as such, this thing it's very wide, it's very long, and it's sort of a brute. Whereas Thorne Buckingham is a little bit more controlled. He'd prefer to go around an obstacle rather than over it if given the chance. And so this rig is a little bit narrower. It's going to be a little bit shorter, while still kind of borrowing a lot of these design elements. And so that brings us to a slightly shorter trailing arm. And in that, we're also going to try to get a little bit more weight out behind the axle as well, just to force that thing to work. And so I'm curious to see what sort of dynamics it will have when going down the obstacle ramp. So looking forward to kind of playing with it. I'm not a professional real vehicle designer by any means, so I'm not an expert in vehicle dynamics, but I read a lot and I'm interested in it. So we're gonna translate my limited knowledge here into toys. And so we've got, this is kind of our center line. We're picking up these 2 points. I'm going to turn this sketch off. All right, so we're in the trailing arm sketch. Just going to hide this part too so we can kind of see. And I kind of like to, over time we're developing sort of a ClickRigs style here. And so when you look at a component, it should, even though it's a new component or a different component, it should fit in aesthetically with the other pieces. And so wherever we can, or at least wherever a good precedent has been established, let's go into the model catalog. We try to stick with it, just so that there's some aesthetic continuity between everything. So right now I just jumped over into the model catalog, which is sort of the repository of all the current parts in the ClickRigs system. And so as I'm designing, if I'm not designing a new part, I can come in and just add any part that we already make from any of the other kits into the design, rather than just like remodeling and rebuilding something specific. And so what I'm trying to find is one of the trailing arms, just so I can kind of reference some of the dimensions on those ends. There's that. And so what I'm looking for, I just kind of want to know, what diameter am I using here? 3.278. That's a very strange diameter, but that's okay. So we'll just, we picked up the whole diameter from that grid reference, and so those are all the same because they all basically work with the snaps. We want these to be the same, so we'll select them both, hit E, and add an equal relation. And let's just, it's like 3, 6. I'll just call that 7 for now. Okay, so this is a trailing arm, and it's going to be real similar, a similar kind of spring setup to the Mayday rig, where we've got our quarter elliptic TPU spring essentially, and then we've got these ball end links, and I can this is just basically a spherical joint, kind of like a rod end, and that on this link, this ball end link. And these come in you can get these, and you can get a kit that has a bunch of different lengths of these, and that essentially lets you tune your ride height by swapping in different ones, and they just they pop in there like that. And then there's also a kit you can get different spring thicknesses, so you can adjust the spring rate and the ride height somewhat independently to kind of tune these. Same on the front end. This spring is a butterfly spring. It's just all one piece, and here they're independent. But on the rear of the Thorn Buckingham rig here, we're gonna keep kind of with this general plan and use this style of spring and the ball end link. And so what we need to do is we need to kind of figure out where we want the spring loading to come into the trailing arm, because that's sort of going to be our thickest, most robust point. And so the way parametric CAD works, we don't need to know exactly where that is ahead of time. We can just design the layout that's kind of a rough approximation of the final dimensions, and we can just add a dimension, and then you can come back in later and just add in change the dimension to the correct number, and then if you've done the sketch or the model correctly, the whole thing will just update to reflect that design change, which is nice because it lets you get to designing without having to know every single detail ahead of time. So let's do a construction line somewhere. We're just going to kind of randomly place it just like that. And now the other thing too is this trailing arm is going to be symmetric about this axis, and so we really only have to design one half of it, or sketch one half of it, and then we can just mirror the rest of it. And that often is a more reliable way of going about things. So we're just going to do a line here, hit Q because we do not want that to be a construction line. And then we're just going to add a tangent relation to these lines and circles. And now you kind of see we can just drag this around and make it wherever we want. I'm going to, and then let's add a dimension. For all the links, I pretty much, all the driving dimensions go to the sort of the center point of the connector. It's just a nice reference. And for now, let's call that 25. And we can mirror that. And so we've constrained, the side to side, but we have not constrained this. And we could delete that dimension for now. As you can see, we can just kind of play with it so that between aesthetic considerations and functional considerations, we can start inching our way toward a final design. This length is probably, I kind of want to set it up so that we can use the existing set of quarter elliptic springs, because we have a whole bunch of different thicknesses, and that way the tuning kit will work for both the Mayday rig and the Thorn Buckingham rig. And so the distance from here to here will sort of be driven a little bit by that spring. I mean, we can move the spring around, but let's start with that assumption. And so, that's approximately there to there. Let's look at what the center distance is. That's kind of interesting. I see what's going on. It's because this part is sort of rotated in the coordinate system. I'm just gonna another thing I just want to check is the spring itself. $26.697. $28 roughly, we'll call it. So what does that look like if we bring it straight up and down? It's about right there. Let's just run with that for now. I'm curious too, sort of what's our width here. 10.5. What's our depth? 7. I feel like these are a little shorter, so we can probably make it just a smidge narrower. So you can kind of see everything's turned black, so it's fully defined. Whereas, you know, if we don't have the dimension or relation to define it, everything that is blue is not fully defined, and everything that is black is fully defined. So you can kind of see. And I'm just going to keep repeating this because it's such a key concept in parametric CAD, and it's honestly one of the things that makes sort of sketching in it so awesome. I don't know if anybody makes it, but I've often felt like there should just be a 2D sketching program that could like run on your phone that operates sort of like Onshape or SolidWorks sketching tool, because you can actually do a whole lot with just a 2D sketch. You can kind of build a whole mechanical model, at least on one two-dimensional plane, that simulates and lets you kind of like work out linkages and leaf springs and a whole bunch of stuff that really can just be done very quickly in a 2D sort of parametric sketch. It's sort of like having a graphing calculator, but for mechanical geometry. So if anybody out there ever hears this and wants to make a parametric 2D sketching app, that would be awesome. Anyway, let's add that dimension back in. And so yeah, these black circles, that's what I was saying, these black circles here, that's fully defined. You know, you can't do anything with it. But then these blue lines are not fully defined, and so it's partially defined but not fully. But as soon as we add that dimension, everything turns black, so now nothing can move around. So right now I kind of like that shape. That basically means our spring is going to come in here. Hold on one second. I'm going to turn off one of these dryers because I can hear it. All right, that's better. I don't know if any of you could hear it, but I can, so. Okay, so now what we probably need to do is just extrude this down. I've already forgotten the number, but .767. This is a little shorter, so we can probably, let's call that 6. So now we've essentially extruded that down. I'm going to hide everything else just to let us work here. And you know what? Actually, that's not. I'm sort of jumping back into this. It's been a little bit since I last designed a kit, and there's a better way to do this. So we're actually just going to go 0.8 millimeters down. And the reason for that is that essentially gives us the pivot thickness. So all of the pivoting joints in the TPU, as you can kind of see, are just done by making that section thin. And for those, I do 0.8, which is I think what four layers using the parameters that we print at. And so that strikes a nice balance between being like incredibly durable and also quite flexible. So we're going to make that 0.8. Let's actually go so now we've got that, and then now we just need to add some let's go to the bottom here, the thicker components. So let's do a new sketch. I'm just going to use these edges, but what we want now is for that, you know, we don't want the thick part to continue all the way out to the thin part where the pivot is. And let's kind of take a look at this one. So essentially we're going to be adding this thicker component here. And the question is, how far out? It's like 5 plus, is that 4? That's like 7 to the center. We do the same thing over here. You need to provide enough clearance so that as this pivots, the thick part doesn't hit. Yeah, so I'm doing about 7, and that seemed to work really well. It's a little bit dependent on the particular rig and what that joint looks like, but let's do this. Let's do a couple lines. I don't know, 7 to the center, but 5 to the edge of this hole. We'll hit M, we'll trim these up. We're just going to start there. We're going to do an extrude. We're going to add. And we're going to go. Let's see if we can do a little thing. We're going to go up 5. Just like that. And then I'm going to create a centerline plane. I'm going to do a new sketch on that. I'm going to hide the plane because I don't like seeing them. And now what we're going to do is we're going to kind of design the side profile here. And the way this works, again, because the loads kind of are, you've got a pivot connection here and a pivot connection here. You've got forces driving the axle up, and then that load is transferred essentially to this point, which is where our ball end link comes in, and then transfers that upward force into the spring, which the spring resists. And so this component right here needs to be the thickest part. So we're essentially kind of doing something like this. I'm just going to make this a box so we can kind of extrude this out. And we've already determined our max thickness, so we'll just add that relation there so that never really undercuts. If we want to, we can just get there. So now we're essentially going to cut out 2 sections. And we can sort of drag these around. Okay, so now these are defined with the exception of kind of like how far in these angles come. And I think what we want to do, there's a couple things we could do here. So if we know this is going to be where the ball end link comes in. So we could say, let's say we knew we wanted these to be sort of, or that ball end link location to be centered around this. So we could select these and do a symmetric relation, which now means they're going to stay, and then we can go in and we can add a single dimension, and that should fully define it. So let's say that's 8, and so now that's fully defined, and we can just, for now, we can just go ahead and let's do the cut. We're going to go through all. We're going to do through all in both directions because we are centered, and we're not going to add, we're going to remove. And now we've got kind of that. And it's getting there, but it's a little bit ugly. These don't need to be upright. We could go and do another sketch this way and do that profile, but I think we're just going to do that with a draft. And we could draft it separately, but I bet we could go back into this one and we can just add the draft here. As you can kind of see, let's kind of do something like that. And of course we've broken our sketch. That's okay. Let's go in and we'll fix it. Probably because this line changed, and so it didn't like that at all, did it? Now this is a mystery. Why? Let's show all of the interesting. Okay, so sometimes you just gotta kind of like play around and let's extend this. Well, I got messy real fast, but that's okay. It's also not what we wanted to do. Tell you what I'm going to do. I'm just going to start over. This is a simple sketch. There's no reason. Going to add in some of our reference points here. let us do symmetric now. Interesting. I have no idea what's going on. That should work, but I'm just going to go through and delete stuff, see what happens. Sorry, this is boring. We're probably wasting time because there are other ways of doing that. We don't need this relation. It's always cleaner. And I usually like the symmetric, but this will give us more adjustability. Let's call this 3. And so if we want it to be centered, we could just make it half. It's right there. So it kind of works. But I think we want a little bit more of a steep kind of rise there. So let's go back in and change this up. Now let's define that. Cool. Kind of like that. And then we can just kind of do some generally, and I don't always do it because sometimes I like to see the result, but it's nice to add like chamfers and fillets sort of more toward the end, and kind of keep everything blocky with nice reliable edges up until the last minute. Just make that match our color scheme so we know it's a TPU part. actually don't think we need that. Okay, so now what we need to do is we need to insert the ball end link pocket, and just to, rather than kind of dimensioning and modeling that, I essentially just use a Boolean operation to remove the cavity, since I've already got a proven shape for that. And the way we do that is we're going to bring it in. It should be in here. And it's the ball and link plug, I believe, so we'll just search for plug. There it is. Boom. And where is it? It's probably like, I didn't like that. Oh, you know what? We might already have it in here. Let's see. Yeah, probably when because we used it on the A-arms, and I would be willing to bet we let that Boolean delete the parts, which we don't want. There it is. Let's keep the tools. There they are. And so now we need them there, but we're just going to transform one. But we're going to copy the part when we do it. We're going to transform it by make connectors. These are designed to just kind of we're going to need a reference feature here. I think if we show the sketch, it'll give it to me. Otherwise, I'll have to manually go in and add a make connector. Let's not forget to copy the part. There it is. Rotate it 90 degrees. Just making sure we did copy it. Okay, and now we can just do a Boolean subtract. We'll just keep the tool. It's probably a better practice. We'll just hide them. That's the tool. That's the target. And so now we've got that geometry, which will allow the ball and link to snap in and pivot. Okay, so that's kind of where we're at right now. I sort of like that that setup. And then what we're going to have to do, similar to these, we're going to add a especially because this is so long. The A-arms don't totally need it, but we just added it here as sort of a performance improvement to make the A-arm setup a little more rigid. But on a link that's this long, the TPU, even at 6 millimeters thick, is not rigid enough to do what we need it to do, so we add a stiffening plate to the top of it. And so we're going to probably do that next. I'm just sort of thinking through, okay, what components do we want to use to pick this up? Probably use the standard chassis side pod. We can let's jump into the assembly now. And what we'll do is we'll add in the part we just designed. Let's add in those components as well. And as you can see, they are not currently mated, but we'll use a fasten mate. Hold down Shift. Maybe that one. Let's see, does that get us? That looks correct. Now this is one component. I'll do the same thing to the other side. And again, Onshape kind of gives you mate connectors that are sort of based off the geometry, and you can, I select this face and it sort of shows me all the points that I can select as different mate connectors. The one I want though is down in the middle here, and so when I'm on this and I go to move, it disappears because now it thinks I'm trying to find a mate connector on a different feature. But what you can do, you can hover over the feature that you want to use and then hold down Shift and then move to select, and that Shift sort of locks in the feature that you're on when you hold Shift down. Just something useful. It took me forever to learn that, and I was always very frustrated with trying to select certain mates, but once I figured that out, it became a lot less frustrating. And we're going to connect it to, see, again, I hold Shift. Interesting. Let's yeah, we actually want that one, I believe. Okay, so now this component is an assembly. And I just kind of want to get a rough idea. So we're going to go into our model catalog that has all of our pre-existing components. And I've got something called a chassis side pod, I believe, that is yep. Was sort of designed for this purpose. We use it on the Mayday rig. Yeah, so that essentially would go in there, and that could pick up, and then it provides clearance as well. So we'll probably just use that existing component. I don't have another feature to mate off of. I'm just kind of eyeballing roughly where that would go. obviously we'd have another one on the other side. And then what's nice is we can use this link or this link depending to pick up kind of our triangle. And so we'll just keep with that theme because that's been working really well. And then our quarter elliptic spring can kind of come off these. Hey, no barking, buddy. No barking. Okay, so yeah, I think, you know, maybe we'll make some revisions to that, but that's been a pretty good system, and no need to redesign every component if you've got a perfectly good one that already works. Hey, no squeaking, no squeaking. All right, let's jump back into the truck layout. And so now what we need to do is design the stiffening plate here. Again, we'll just hide the other parts. So we can just work on this one. I'll do a new sketch here. Kind of similar to how we did for the A-arms. I'm just going to use these edges. Draw a couple lines. Let's trim these up. Technically we don't have to do this. I just sort of like keeping the sketch clean wherever I can. I will use those so I can dimension to the center though. So this is going to be the edge of the stiffening element. So we want it to stop wherever it stops. You know, we're going to start getting flexibility, and we want flexibility. But one of the what we want the stiff part to stop there, and then have everything outboard of that be flexible. And so we could hard code this. With a dimension, but another way we could do it that would make it more adaptable is we can essentially put a relation, a coincident relation between this feature of where the thick part stops and where this sketch is going to be. And now if we were to go in and change this feature and go back in the tree and change the sketch for this feature, this new sketch will update. And because we know that wherever this face is, wherever that ends, that's where we want our stiffening plate to end as well. And so since this is defined first, we could let this definition totally drive that. And so that's what we're going to do. Obviously this is fully defined. And then we need a little cutout around here. And so what I did is a center line between that, and I'm going to pick up this center line point. And then I'm just going to draw a rectangle, and we're going to do a symmetric. And again, covered this last time, but just like the shift command for selecting mate connectors, This is something that it took me forever to figure out. But when you box select stuff, if you select from left to right, you only select things that you've completely enclosed in the box. And so, if I do like that, I'm only getting these things that I completely enclosed. But if you select from right to left, you'll select anything that the box touches. And so you can see all those things. And so in this case, I want to select this line, and this line. So the quickest way to do that is a right to left box sketch that just touches them. And then we can add a symmetric mate. And now we've got, I think. Oh, I already added that one, that's why. There we go. So now I've got a rectangle that basically stays completely centered in the X and Y. So let's just do some dimensions. And again, just for aesthetic consistency, I just kind of want to roughly match this. So 1 millimeter radius, and then half a millimeter. If there's one thing I wish Onshape would do in their, or fix in their sketch, is when you go to add a fillet between two objects, I wish it could do a little bit of at least initial calculation and just guess at a fillet dimension that fits within the geometry that you've selected. A lot of times, especially on like little tiny things, the initial radius it gives is too big, and so you end up with like these big red lines, and you kind of have to adjust it in. I think it should be smart enough, in my opinion, to look at what you selected and just say, okay, I'm going to make a radius that's like 1/8 or something of the smallest line that you selected, just to make it work right out of the gate. I mean, you always pretty much go in and dimension it anyway, but it's just kind of an unnecessary step, in my opinion. I don't know what the hell happened there. What it does do is it remembers the last dimension that you used while you're in that sketch, but that's not always what you need. And so now let's extrude that. I'm going to go new part, 2 millimeters thick. And actually, let's go back. Let's do that as a draft. So that'll get 20. again, just kind of keeping, chamfer sizes and fillet radii, kind of like windows on a house, right? I don't know if any of you have seen that video about McMansions, but one of the defining features of the McMansion is sort of a semi-random collection of different window shapes and sizes that don't really seem to work together. And so I sort of feel like chamfers and fillets are similar. You don't want, and it's also kind of like using fonts. Like you don't want too many font types or font sizes. You kind of want some kind of a structure or a scheme where those are intentional and used in different sizes or used in different circumstances that follow some kind of a rule, but without too many options. Otherwise it makes the design look kind of messy. So I kind of like that. I also kind of wonder, let's go to translucent. I wonder, this link's a little shorter. I wonder if we could thin that up a little bit. Probably by at least 1 or 2 millimeters. Let's try thinning it up by. Okay. I actually think we'll just leave it at the 5. I think that's a good balance, because we can't make this, basically the thinner this part gets, the thicker that part has to get, roughly speaking, and so I think it becomes a little bit unbalanced top to bottom if we go too thin there. Okay, so now we need to add, let's hide the other parts here. We need to add the snaps. And so on these we just did a center line row. Did we use a consistent spacing? No, not really. Which is fine, because these components always go together, so you'd never use like a stiffening plate on a different, from one trailing arm to another. They're kind of a matched pair, so these little snaps aren't part of the grid system, and they're really more designed to apply a connection sort of where it's needed from a functional standpoint of the part, so kind of constraining around that. I do think getting it kind of close into the pocket though isn't a bad idea, so let's start with a center line. I'm just going to do, I always say those are 3. And I'm just going to pick up a center line centered around the snap dot. I'm just going to mirror that part because I want these to be equidistant from where the load comes in. And then same, you kind of want to pick up the farthest ends. In this case, I think we probably want one more to sort of in the middle. Trim that out, and then that'll let us select a midpoint. And that's fully defined. And I did it that way so that, like, if I decide these should be farther outboard, as these move out because they're symmetric around that, which is the important definition, and then this being centered between these two is the important definition, that will move. Now, part of the issue is I think that might be a little close because these get drafted out. So let's just kind of do 3 for all of these. Again, you saw how that bumped into the center. We're going to extrude these. We're going to go up 3. It's going to get drafted. I think it was 3 degrees. I'm going to have to go in and double check that again. I'm going to double check that just by finding where I did that. 3 degrees, and it goes up 2. Point 6. Let's just rename that now. Call that a 70mm trailing arm. Let's rename this part 70mm trailing arm stiffener. And then what we're going to do is we're going to subtract that and keep the tools. This is the tool. It's the target. And now we've got our snap dot holes. Let's just check, make sure nothing. Go to the translucent view. We're just kind of making sure that none of our snap pockets get too close to anything critical. Looks good. I wish there was a key command to toggle between translucent and shaded with edges. Okay, so I think that is pretty good. I'm going to take a quick break, and then when we come back, we are going to, I think, throw some components into the assembly and kind of get the base of basically get these side pods connected up with probably a cap connector on the bottom, and get both the trailing arms in and connected up to the axle. And then from there we'll figure out probably how to attach our springs and then do the triangulated link. So I will be right back. All right, we are back, and we're in the assembly here. So let's. And I don't know exactly what like this this stream and this channel will become exactly, but I do sort of enjoy the streaming. And the thing that keeps popping into my head, and this is not, I'm nowhere that good, but the sort of the model that pops into my head is like a ClickRigs CAD Bob Ross. Just, sprinkling a little bit of chamfer right here. I like the idea of people throwing this stream on in the background and just kind of letting the soothing sounds of off-road toy truck CAD design lull you into some form of contentment. Dare to dream. The upside is I usually kind of mutter to myself constantly while designing things anyway, so this isn't really much of a stretch. I'm sort of making a half-hearted attempt to be somewhat more lucid or intelligible, but other than that, it's this is my process. I sit in front of a large screen and stare at 3D shapes and mutter to myself. Okay, so here's what we've got. Let's throw that stiffener in. Am I just missing it? It's got to be in here somewhere, right? Okay, so let's fasten this. I'll make a duplicate of that, which should come in already fastened. So it's kind of like a little sub-assembly. And we're going to need another one of these. And we're going to need something to tie these components to the Domino chassis. So we probably have something in the model catalog that will work. I think we'll start with let's see, what do we use? Yeah, probably just, was that a 3x5 skid plate? Will work just fine. Although I kind of want to leave a spot. So the TPU springs work great, but the problem is if you leave them like sitting like this, loaded up over time, they tend to sort of sag. And you can restore that by essentially raising it up so it droops out, and after a day or so that springiness will be restored. But what's even better is if you store it kind of in that state, so when you're not using it, it's not compressing the suspension. And so the plan is to make basically some display stands that also then let you store it, so that as soon as you pull it off to play with it, the springs are in tip-top shape. And ideally to do that, we just leave some of the snap connectors open on the bottom, and so that stand you can just kind of like plug it right in. Which means if I use that skid plate, we won't have any accessible holes. I think I'd like to probably leave 2 of them open. Let's see. So 2x3 would probably work there nicely. I don't know if I have one. If not, we can make one. But let's let's look in the model catalog and see what we've got. So that's our 3x5, but again, I think what we really want is a 2x3. I'm sure I've made one, but it probably never ended up in any of the kits. We've got sort of these, which were for leaf spring clearance. So that's a 2x3. I wonder if we could make that one work. Potentially, and then give it a little like swoop out to there. Which actually could pick up. That's interesting. That might pick up our trailing arm, which would be a very robust way to connect it. So let's actually try that. What number is that? That is a CR 122. So every single component has a CR part number. Go other documents, model catalog. Okay, so let's see how that works. Let's fasten. I think just like that. And then let's do yeah, so that's actually kind of perfect because that little nub picks up our trailing arm connector. I think it's that one. Sometimes my brain gets those confused. Yep. And then that leaves that whole middle row open for a stand. Picks that up nicely and then ties that load from the chassis connection of the trailing arm into what is that? 7 snap dot connectors, which is going to be very robust. And then these get connected with a spherical connection, which is always a ball mate, which is always kind of wonky. And again, this is going to be, it's going to interfere, but that is okay for now. I'm just going to hide these two things real quick, just to make sure we're selecting kind of the same. Now you can kind of see these things can move like that. And then we're going to do a similar ball mate there. And so now we've probably got a very uncontrolled axle, but it is realistically constrained. And then probably what we'll do is the triangle connector that will probably pick up. Actually, I am dumb because that is not where that comes in. That comes in there. So we're gonna, let's go fix that. I thought that looked a little funny. That's better. Much better. So that's what that looks like. Kind of liking it. It's got kind of a, especially with these straight sort of trailing arms, I kind of like, it's a nice high speed but kind of blocky squared look, which I think is going to be kind of cool. It'll be interesting to see how when we do the cab and the and the hood and the tail section, kind of playing with some of these shapes that this creates. It'll be kind of fun. Okay, and so we've picked up that pivot, and then we've got this cutout kind of gives us clearance. We may need to end up adding a little bit of clearance there, but we'll see. let's get the triangle in. And I think the triangle link, which will go from here, I think it'll go from there to there. You know, the wider we spread it here, essentially that triangle link controls two things. It controls the side-to-side motion of the axle, and so for that, the wider it connects at the chassis, the more rigid and stronger that will be. Whereas if we connect it kind of like here and here, that will work as well, but the base of that triangle, the base to the sort of the height or the length of that triangle, the ratio skews, and so the wider it is, the better. And then the other thing that triangle controls is the rotation of the axle. So let's jump back into the truck layout. Hide these parts, and then let's go back in and turn on our grid. And so we're going to use these 2 points for our triangle. And that's we're pretty much going to pick up off of here. So 10 millimeters, kind of a chassis thickness offset. So we're in a new sketch, and we are going to pick up this one, this one, and this one. So now those are our connection points for the triangle link. And that all matches up with the grid. So we should be able to turn this grid off. And for now I'm going to hide the axle just so we can kind of get a sense of our components, and we're going to draw some center lines. This is going to be all one piece, so these are all going to be the same size. I'll just make it equal to that. So and essentially this one can really be kind of straight because it doesn't need a lot of stiffness and bending. We're not feeding any like spring loads into it. Make these tangent. Can mirror that. We can These are probably a little too thick. We might get rid of that equal dimension. I think we can make that thinner. Let's just trim. Trim that up a bit. I think that's going to be too. Let's go back into here and let's find, what do we do on the Mayday rig? Because that, I know that's thinner, but it worked pretty well. .588. If I had to guess, I would say that's a line thickness thing, but printing. Regardless, let's call that 5.6. My guess is what I was going for. Let's delete that dimension. So this is fixed. That's a 4mm hole because that's what lets the snap dot or the snap studs pass through. But what might be critical here is that distance, because we probably want a certain number of walls, which are like 0.42 millimeters in our print settings. So if we go, what does that end up being? 5.680. Let's just double check that. Not quite, but I think I'm going to stick with that. So I don't know what I was doing on the other one. Cool. So let's extrude this again, 0.8. Hey buddy, been running around? Change this to reflect the TPU material. Okay, so that's looking pretty good. Okay, and so now our stiffening bit is going to go here, which means the underside, the bottom of this part, needs some thickness. So similar to the other bits. just and so these we actually don't want. This one we want vertical, but these we actually are going to want perpendicular. So it's going to mirror that. Again, don't really need to trim these, but I think I want to add the fillets in the sketch here. Curious what this one is. 3. Oh, look at that. And let's draft that. The other way. I think that looks pretty good. And then similar deal, so now we're going to add, similar to that, we're going to add a stiffening plate to the top. Same size snap system. You know, we can probably do. Like that, we can press use, and now we're just using the sketch that we used to make this thickness, but we just moved it to the top plane. And so now those two should stay kind of matched. So we could do that there. What I'm wondering is if we, let's go to the overhead here. So on the Mayday rig, you can kind of see this is our triangle connector. And it does a pretty good job of controlling the side to side, but you do get a little bit of play just in the flex, kind of in the joints. So one way to control that is essentially by moving the stiffening elements closer to the pivot. And I was conservative on this one, but I think I could move that in at least a millimeter, I think, without too much issue. But the other thing I was thinking is about maybe bridging the triangle in here. So instead of bringing it in quite as deep, we can kind of move it outboard. We're not trying to get around anything, so we're not trying to package it. So there's no real reason. So we're going to use that sketch to draft, not 320, 20, the other direction, make it a new one. Just like that. But I think I want to move these stiffening elements in closer. So let's go back to that sketch. Just do this from the top. I think maybe we just do a big fillet, like almost something like that. Broke that sketch though. I don't really want that much TPU there though. So we won't really be able to do it in that way, so we're going to have to go back and make that too. Oh, you know what? Let's go back to this sketch. Let's make this just a little bit bigger. Okay. this point we're just going to go our own way. And I actually don't think I want a big swoop there anyway. I didn't like how that looked. But I do wonder if we do something like this. It's not perfect, but I like that a little better. The other nice thing that does is it gives us a little bit more contact area on the build plate, because sometimes these long, thin parts have a tendency to want to pull up. Actually, I don't think we need to shorten these up. I don't think we can get away with 5. But I think we can get away with 6. Okay. Let's throw that into the assembly and see how we like it. And we'll use the ball mates. Sometimes they get a little wonky. Fasten these together. Oh, you know what? We're close, but not quite. We need to add our snaps. We forgot a critical element here. We'll use our little center line trick. That's a lot of snaps, but it's nice. This is a pretty thin part, so the more we have, the less bendy it will be. Add our fillets here. And you guessed it, go back in, do our Boolean subtract. We want to keep the tools. This is the tool. This is the target. Isolate this real quick just to double check. There it is. Awesome. Now we can jump back into here. And we've got our feature to mate them together with. And do that with a fastened mate. And you really just need to pick one because it uses the mate coordinate system. And so now that's an assembly. And so we should be able to use our ball mates again. And because that's a single part, this is one body. I don't think, well, maybe we do. We probably do, because it's a ball. I don't think that will over-define it. So in theory, this should now be pretty constrained. And I found, though, that with these ball mates, like you can kind of get it all like messed up, and it's like a Rubik's Cube you don't know the rules for to solve. And so the easiest way to kind of deal with that out of the gate is to add a limit to something. Probably to that mate. Which is this one. And I'm still kind of learning how to work with the limits of the mate. Maximum angle, let's start with 10 and see what that gives us. Once we have the springs in, I actually dragging around by the springs is a nicer way to control this. It doesn't quite glitch around like that so much. Again, these can roll too, which is similar to real life trailing arm wobble, which is why, a lot of times if you've got a rod end or spherical bearing there and there, you kind of draw a line, and if you bring your coil over below that line, it tends not to want to like flop over side to side, and you can get like anti-wobble things there, but it's nice to start out with a decent geometry so you have a fighting chance. And so you kind of want to bring your loads in below, and that has the effect of wanting to stabilize it flat. Whereas if you, let's say you had your shock mount kind of on top of that line between the two spherical bearings, it's going to want to flop that thing over. Let's go back to that, because 10 degrees is not enough. Let's try 20. That's probably more than enough. But we're essentially controlled side to side. We can articulate, we can move up and down. I'm just going to carry this up there. I guess that's a total angular limitation. But that is essentially our rear linkage, and so it's kind of a nice compact little truck, almost square. It'd be really interesting to see how it does. And again, these ball mates are approximate, right? Because the way we get that multi-axis degrees of freedom is by flexing this material, but we can't really simulate that in CAD, so we're just going to allow the interference to happen for now. We can probably, it doesn't fully simulate the linkage, but just trying to think if there's a good way to sort of give it a little bit more control, but we'll just do that with the spring. That's actually, we're going to reuse springs, so I think we can, let's find one that we want to use. It's kind of a shorter arm. I actually think we might be okay with the stock Mayday spring. That's the CR35. So let's just bring that in. And then these are asymmetric, so we'll bring in the driver. My guess is that's either 35 or 36. Yep, for the passenger. Which we actually might not want, because these kind of flare out to match the wider axle of the Mayday rig. We might actually want one that's straight, because if we kind of connect that where I'm thinking it's a little bit outboard, we don't really want to bring it in there. Let me see if we've got just some straight springs. Yep, that'll work. So in the model catalog, the default color for TPU is orange, and what's kind of nice about that is that we really should probably do that for these too. When you start designing a new rig kit and you've got an assembly, it sort of lets you know what parts are pre-existing parts from the catalog and what parts are new that you're going to need to onboard into the catalog once this kit is done. We'll do that kind of at the end of the day. I'll change the coloring here so that all the new solid parts are a slightly different color than the model catalog parts. Like this one, these three parts are catalog parts, and so are these two parts. But anyway, let's get our spring in. rotate that around. That one might be a little thick, but we'll try it. I'm going to swap it out if we want to. And now let's insert a ball end link. We have a bunch of different sizes. $22 might be good. These also get a ball mate. And so the way that works, kind of select the center of that ball. And then same thing again. And then up here. But apparently I did not do that correctly. Let's just fix this temporarily. I'm just going to fix it in space so that we can and I forgot some the springs that we need to get this to articulate and actually need to be split, and then a revolute mate added. And so unfortunately that won't be these springs, but let's just delete these real quick, and we'll add in this other ball mate. So that's good. Sometimes I like to just add a parallel mate to these just to keep this a little more controlled. Although this might be inset a little bit, so we probably can't get away with that one. That's okay. Let's fix this one again real quick too. That's just temporary. I'm just going to temporarily fix the trailing arm in so I can move these around without moving everything. And so let's see. I'm sure I've got some articulating springs. Let's just go let's just rename this. This is what we use to sort of split up the flat arm pattern. So let's just rename this, and we'll just call this our articulating bits. And let's derive in a spring from the model catalog, and then we'll split it up. I do think that one was a little bit thick though. That's probably good. So we're just going to split it. We might need to make a plane. Let's do it there. Oops. Perfect. Split. Split with this plane. Easy. I'm going to insert both of these bits. And we're just going to add a revolute mate. Do another one, and then now let's fasten these. And so now we've got kind of a spring that roughly simulates flexing. And in theory, we should be able to go in and add our ball mates. Okay, if we unfix it kind of works, but another way we could do it is we could split it there and just make that a revolute and kind of fix that so it's less wobbly. I do wonder what happens though if we were to do a parallel mate between that. Does that constrain well? That helps. Let's try another one here. Since I'm just making these kind of stop wobbling around. That helps. So what I found is kind of controlling the axle by dragging the springs around tends to let you have some decent control. And kind of showcase how this articulates. That looks pretty good. So that's kind of our forelink. Let's see, let's put this kind of in a rough sort of ride height position maybe. So one of the things I don't like is how far back this kind of, or forward this angles, I guess, or back at the top. So I actually think this spring needs to be, either the spring needs to be a little bit shorter or we need to move this spring point farther back. It's nice that for whatever reason, at least in this, I'm not saying this applies to real vehicles, but for whatever reason with this quarter elliptic TPU spring and four-linker end, they seem to work better with a little bit more leverage on the spring. So I'm hesitant to move this farther back. I think a shorter spring might not be a bad idea. It's also possible that I just chose. Let's go back into articulating bits. So I think that's a 32. I wonder if we have a shorter one. That looks like a 22. Yeah, so like a 26. So we go to the top. We're like 26, so some of those other springs I think just aren't quite the right length. Okay, so I think maybe we just design a spring for this. Might as well. Let's turn on the our layout. I'll pick up those two holes. It's interesting. That's very strange. This is our plane. Why do we have What happens if we just... That's a weird visual bug. It's like it kept the points. This is going to be a straight one. So let's mirror that. So let's extrude. Five millimeters connector height. We're going to need a ball length connector. So we're going to move that plug. And that's okay that it kind of pops out there. In fact, it's good because it means when we're in full droop, we're going to need that clearance to get a little more angular travel on that. Just going to get a little bit of a fill it there. And then what we can do is we can go and we can like cut pieces of this out, and we just need the 5 millimeter height right there. In fact, one of the things we can probably do. Oh. Let's give it a little bit of an undercut there. That works for now. We'll probably tweak the style before this finally goes in, but let's make this articulating. We're just gonna delete these. I forget, can we derive that in? Or is that a universe destroying? Okay, so it just wants me to bring it in. At the same time, so one derive. Nope. Can I not select multiple components here? Okay, good. So now we're just going to do a split. Split with that face. Call it a day. Now go in and we're going to fix everything that broke here. Look at that. Delete those parts. I'll insert our new spring. Actually, that is in articulating bits. Gonna add a revolute mate. Very nice. Let's do a second one. Just fasten this. I'm dumb. I didn't add a revolute mate. I added a fastened mate. That's right. Easy enough to fix. That's better. Okay, so now we can go ahead and Add our ball mates again. So when we did that, it inverted this, which can be hard to fix. So let's just kind of undo back to where we like it. Temporarily, we are going to fix this in position and go back and add the ball mate. I don't know what it's isolating, but it doesn't seem to work. So okay, so we're probably just going to have to delete these parallels, unfortunately. Not too surprising, but had that fixed. So the way I solved this in the Mayday assembly is I just made that revolute so that these couldn't roll. It's not as quite as realistic. Can we do a does that overdefine everything? Does not like that one. Again, we're cheating here a little bit, but let's just let us see the droop anyway. Okay, so I think that gives me a good enough sense. And so the next step is we're going to print out all of these new parts, and then see how they fit. We'll kind of make adjustments from there. I mean, right now we just kind of wanted to get a general sense of the articulation. We don't actually need to cycle it. I think to do that I just have to change one of the mates on the trailing arm. Well, let's get these parts printed here. So again, these trailing arms are symmetric. So that part, that part, that part, that part, and the spring. I think that's everything. The other parts I probably have. Although, you know, might as well print some of those too, just in case. We'll just bring all of these parts into the slicer and get them going. Can we select both of these? I'm sorry, say no. Okay, let's pull over all the rigid parts. Need two of those. 2 of those. Slice that up. Get that printing. Let's go over to here. I need 2 of these. I need 2 of these. I need 2 of these. These are all going to be PLA Pro. We get these printing, and it's about half an hour. Oh, it's got like an hour and a half, so might not get this assembled today, but we'll be ready to get the rear assembled first thing tomorrow. Definitely curious if that'll be too short, but I think if we can get enough weight out back, it should run pretty well. I'm even wondering if we can squeeze 2 spares back there. Might be a little much. Once we get it together, we'll kind of see how the balance feels in person. Let's take a look at the bottom here. You know, we're gonna need something to tie these together. Probably just a 4x4 cap. Let's just add another wheel in here. Just kind of get some housekeeping things. And I'm pretty sure parallel is just going to over constrain it. I guess I could probably add some limits here. That might. I wonder if we added it to here. Problem is that's a lot. Let's do this one. It helps. Let's sweet. Close enough. It's good enough for now. We'll get closer to doing some renders. We'll improve the articulation, but this model at least lets us check kind of interferences and movement and overall look. Layers are looking okay. And so now, let's see. What next? Could jump into kind of cab and hood design. I'm also wondering, let's go to the overhead here. So for the tail section, you know, on the Mayday rig, you basically just have this piece which kind of cantilevers out off the top of the cab, and that way it definitely works. Basically gives you a big lever arm to hang the weight of the spare off to keep the rear working. You know, we need clearance for the forelink to kind of move in there, but it would be kind of cool to bring this down a little lower, and then maybe wrap it around and do something where we could throw some fenders on it. I'm not exactly sure how to do that just yet. You know, if we can have a cab. Say that's, yeah. And so that's like kind of roughly full bump. Oh, we can go more than that, can we? And that's probably pretty extreme. Close enough. So that kind of gives us a rough idea of what we have to clear. You know, our cab, chassis height's 10. Let's say it's 4. Cool if we can kind of taper it up and then around. I think I'd like to bring the cab just kind of out in this square. And then same for the hood. Kind of, if we want a hood, let's say that comes out to kind of like here, you really kind of have to like come up to the same height, which is pretty dang high. So this is another one of those kind of stare at the screen a little bit and drool, because we've reached the point now where we're sort of back into new territory. I mean, I had a pretty good concept of what a triangulated 4-link needs to be, and everything was just sort of a matter of altering dimensions a little bit. But now we're kind of into the, okay, how do we want to do the cab? How do we want to make it different? What sort of style is going to reflect, Thorne? What sort of aesthetic is going to affect or reflect Thorne Buckingham's kind of sense of style? So we're not just going to reuse the Mayday cab. He's going to get his own cab and hood and grille. And then the real challenge with these, ClickRigs cars is, how do you do this tail section over and to hang out the rear end over this 4-link, and not just make the whole thing massive? Because part of the aesthetic of these is that the tires are kind of a little bit cartoonishly oversized compared to like a real vehicle. So you get a lot of the design cues, but it's not meant to be a scale model. So some of the proportions are intended to be sort of skewed. Which means we can't just make the whole body big enough so that it's easy to clear that and hang past it. So how we do that in an elegant way is the challenge, especially with this particular suspension design. When I move into the stadium trucks, I might actually do like a pan-hard link to locate the axle side to side, and a dual 4-link, so that we can get rid of this triangulated section, so we can kind of bring the body straight back within it and keep everything a lot lower. Especially those will have a little bit less wheel travel. One of the things I do think with the hood, so if we go, let's go take a look at that. The Mayday hood is it's a 3-piece hood. Those are the two fenders, and then the center section, which you can kind of see here in these kind of snap apart. And the idea for that was so I could get them to print flat without needing supports for this indent, but also it kind of makes it so that these, if you come down on a big impact, the wheel will hit this fender and kind of blow a single fender off, which is kind of fun to see. But then for like the Earl Motors kit, kind of did the hood in a different way. So this one's actually printed printed vertically like this, which actually gives you a really nice finish quality. Excuse me. And lets you do kind of some more interesting shapes in the frontal profile. And the pickup points use squares since it's printed vertically, and then the little snap studs, which kind of add snaps to it. And then we've got these 3 snap dot connectors, so you can snap the grill in place. And so I kind of think I want to use this technique, this vertical printing, so we can kind of get a slightly more complex hood, and in a grill. But what that shape needs to be, I don't know. We're not going to do a Jeep Commando hood. Could, but Thorne Buckingham's not really a retro body kind of guy, and he's gonna want something that's one-off. I do kind of like how this is kind of blocky, so I don't think we want anything too swoopy. And again, I kind of think this thing needs to be a single-seater. Again, I think Thorne Buckingham is not a listen to a co-driver kind of a way, and at that point, co-driver is just dead weight, so why have it? I think we make this a single-seat chassis, and so I think we'll almost do something like I don't know, like kind of thinking, I forget what it was called, but it was like kind of one of the last iterations of the Chenoweth buggy. See if I can find any pictures of that. It had like side pods, and it was kind of all futuristic looking. I just forget what they called it. Millennium. The Chenoweth Millennium. That's what we're looking at here. So, I'm not on the... Let's go to the browser here. This is kind of what I'm kind of roughly thinking. You know, these big kind of like Formula One-esque side pods, and then a little single seat cage. Almost tried to rotate it in 3D. I think we'll do the front end a little bit different, but kind of a cab that's got a little bit of that vibe going on. I think would be kind of cool. Might even be cool. we should do a rear wing kind of over the spare tire. See if there are some other pictures here. That's from a video game. Yeah, that's pretty cool. It kind of comes out wide and just has this little cab that boops up. Those are some awesome looking cars. I don't know how well they did. I don't know how many I remember when they came out, but I don't recall ever actually seeing one in person. Even though I worked right behind Chenoweth, saw all their Fast Attack prototypes parked out in their parking lot. So yeah, something kind of like that, where we come out really wide, but then the cab just kind of comes up in this section. Let's go back into here. Let's just start. I don't know exactly, but let's just start roughing some stuff out. Rather than overthinking it, just start putting sketch lines down and see what happens. Let's do this. Let's turn on our grid. We can come back all the way to that edge, I think, too, if we're one connector height above. I was going to kind of rough out what those the chassis outline look like. Well, I don't know why we can't Okay, that was harder than it needed to be, but that's okay. Sorry, I kind of stop talking when I'm thinking. Let's see. Yes, I kind of swoop there, and then maybe kind of bring it out and then blunt it. That might be kind of a neat. So let's see. Let's just do a new sketch. I'll just kind of use this as a reference here. Let's do this as an arc. Kind of too much, but we're going to need kind of a double curve there. I am not, my background and my experience is not in coach design or body design, so. And sort of a parametric CAD tool isn't always the best choice for these, and I don't really do a lot of surfacing, but we're going to make something cool. It's got to be printed anyway, so that kind of sometimes lends itself to, if we bring this kind of outboard. I'm just experimenting here, so kind of. That could be kind of cool. Bring these. Kind of in like that, maybe. Let's just give this a. That would be kind of neat. Maybe a starting point. Let's see. Let's extrude it. Let's go. Again, could edit this in context. That's probably what I'll switch to, but right now I'm just trying to play with some simple, rough concepts. I like it from the top. It's still rough, but generally speaking. I kind of want to like bring it down there and create a cutout for the spring. That could be kind of trick. And then yeah, I'm gonna bring in the cab. Let's see, let's just do a very crudely rough this out. And again, this is super rough. We're just getting some ideas here. Let's do a draft. Let's do that as the neutral plane. Say 25 for now. Super goofy, but see what it looks like anyway. I mean, kind of not bad. I think this is too circular, so we'll kind of probably break this arc up a little bit, but I also kind of like that mostly circular. So I think we're kind of onto something there. I do think we're going to want to blunt these in, but that can be and then yeah, I think we kind of keep that side pod low and we create sort of a nice cutout in there, and that'll work well with kind of Thorne Buckingham's aesthetic, which is a lot more, the fact that he has a lot more resources than Mayday, a lot more VHS tape, aka money, and if that doesn't make any sense, you probably have to catch up on some of the other streams, or I'll talk about the world of Harley Dome more as we go. But basically Thorne Buckingham, compared to the Mayday rigs, has a lot more custom and kind of like finely integrated parts, and so having a cab that features sort of fancy cutouts for the spring is very much in line with the kinds of things he would do. But I kind of like this kind of a buggy truck kind of hybrid, not exactly a truggy, but then we can kind of bring the hood in there. And then yeah, some kind of probably a little wider, bring the tail section out, and then what does this kind of look like it? Yeah, there's something about that that I like. It's not right. It still bothers me to look at, but we're on the right track. I think a lot of this kind of blockiness with a little bit more swoop kind of in it, and then I think that's a nice contrast with sort of the forms. Especially too, you can pull this hood off and then you kind of get a lot more angularity. That fits, but again, it's contrast. So I think that's going to be kind of neat. All right. We did get some parts off the printer. We'll pull those off, and then we're out of time for the day. So we will put this rear end on tomorrow morning, 8 to noon Pacific time. Once the TPU parts are done. But yeah, look at that. We've got a nice little grip of parts we get to play with tomorrow. So if you're watching this now or at a later date, thanks for watching, and we'll be back for part 4 tomorrow. I'll see you later.